In this series of tutorials, we thoroughly go through the Google Earth Engine from A to Z. This series will help you to build your skill and learn how to work with this platform. At the end of this series you'll be able to perform your projects, design an application, use the Earth Engine API in Python and so many other appealing applications of this platform. To briefly explain, the content of this series of tutorials contains different parts. In this series of tutorials, firstly we theoretically introduce the Earth Engine platform, including what is Earth Engine? Or in what fields could we use that? In the next step, we learn about the basics of the Earth Engine, which would be useful for beginners to get started. Then we level up the tutorials to an intermediate level, which is mandatory for everyone who wants to learn the Google Earth Engine. After going through the previous steps, we'll be able to work with different types of Earth Engine data and codes in various fields. Then we change the tutorials routine and turn them to more applicable and topic-based examples. For instance, we go to supervised classification methods and learn how we can apply different classification methods in the Earth Engine. In the following, we test different change detection methods to see how can monitor changes using coding in the Earth Engine. One of the appealing features of Earth Engine is designing an application. In this series we cover this topic as well and programming a few applications. Earth Engine could be used in Python as well, which is another appealing feature of this platform. We show you how to use Earth Engine API in Python. For the next topic we go to supplement and advanced topics which help you to boost your skill. Accordingly, we guide you on how to perform an Earth Engine project and perform a few cases for example. And ultimately the references that have been used for this series will be introduced. But today, as the first episode, we go to Earth Engine's rudimentary introduction. Firstly, using an email we sign up on the Google Earth Engine platform and create our own account. Having an account is necessary, so should not be ignored. In the next stage, we have a data catalog introduction and an overview of Earth Engine catalogs. We also overview the Earth Engine Workspace and explain each section one by one. And run a sample code to see the procedure of running a code in the Earth Engine platform. In the data catalog introduction we inspect Landsat collections and how they are accessible in the Earth Engine catalog. The next one is Modus products and collections. Sentinel products and related collections will be overviewed. And also search for our desired data by considering desired tags in the catalog environment of the Earth Engine. Hi everyone. This video is a comprehensive tutorial video about Google Earth Engine. Firstly, we will introduce the Google Earth Engine, which is one of the most up-to-date remote sensing platforms, which has provided image downloading, image processing and storage space, can be very useful for users. To get started, we need to go to the Google Earth Engine website and sign up to create an account. A Gmail account is required for registration. In the search section, we search for Google Earth Engine. We select the sign in option. To log in, you'll need a Gmail account, which we selected. Then we fill the requested items correctly. And finally, click on the Submit option. In the next step, click on the Keep Exploring option. In this section, we will define a datasets inside Google Earth Engine and enter into the datasets. All datasets are available in this section. You can search the data using tags. As an example, some datasets are available and you can see them. Landsat, Sentinel, MODIS, land cover, topographic, geophysical data. We enter the Landsat section. Landsat 9 data available from 2021 to now. Landsat 8 data are available since 2013. Landsat 7, which has been available since 1999. Landsat 5 data available from 1984 to 2012. And finally, Landsat 4 data is available from 1982 to 1993. All of these data are Level 2 data, which means that these data have been atmospherically and geometrically corrected already. Since the data have been corrected already, cause the faster processing steps. Other data are available from Landsat as well. Landsat images are also available without atmospheric corrections. Collection 2 images are the type of images that have been pre-processed already and have been prepared to be used for processing stages. Landsat images are 30 meters. For example, we go to the Landsat 8 images. Here we entered the Landsat 8 images, where all the information can be seen well and you can decide which images to use. CF mask means we can mask water and clouds. The data are global and we can use them for most regions of the world. This data belongs to USGS, which is also mentioned here. A brief descriptions related to Landsat 8 images. The number of bands and the type of bands have been specified. The image resolution has been specified in the bands section. The explanations related to each of the bands have been fully explained. Here is the QA band, which is aerosol attributes. It has a series of attributes that can be used to remove, for example, the pixels that are water. The visible bands are known as SR. And thermal bands are known as ST. So we have to do all the masks that need to be done by referring to this section. Cloud mask, snow, etc., which we can do automatically. Which is one of the best features of Google Earth Engine, that we can easily apply all kinds of masks on the image in the shortest possible time. In the same way, we can go to the specification of all images and view the sensor and the image as well. At the bottom of each description is a code for use. By copying this code, we can have a visual view of the desired dataset. In the same code that has been put as an example, the corrections have been applied to the image. We enter MODIS data. MODIS has many valuable products. For instance, we have 500 meters resolution for MODIS Daily, or the daily 500 meter resolution albedo product. MODIS satellite consists of Terra and Aqua. 500 meters resolution of daily snow product is available. Daily thermal data is available for 1 kilometer. Various other data are also available, such as daily fire data is available as 1 kilometer. These data has also been derived from MODIS. Like leaf area index is one of these data. Surface reflectance data is available for 8 days and 250 meters resolution. 8-day period of thermal data is 1 kilometer resolution. The burned surface per month in 500 meters resolution. MODIS land cover data are available from 2001 until now. It calculates land cover using several algorithms. We enter the Sentinel portion. Which is one of the most used satellites managed by the European Space Agency or ESA. And these data are 10 meters. Sentinel-1 collects radar images. Sentinel-2 collects optic images, which is more useful for agricultural discussions. Sentinel-3, which is related to ocean and water discussions. And Sentinel-5, which is used for atmospheric and pollutant discussions. Enter the desired dataset. Here the Sentinel-1 satellite is available from 2014 until now in Google Earth Engine. Sentinel-1 tags are related to Copernicus. Polarization is one of the most important tags of Sentinel-1, and the users who use these images are very familiar with this tag. There is a series of explanations related to radar bands. It has fully explained the bands in details. And the angle of the satellite has also been explained. Here is a sample code. The description of each satellite has been presented. For example, there is an instrument mode, which is IW, EW, or SM. We enter Sentinel-2 portion. There are two types of images for this sensor. First one is the top of atmosphere reflectance type, in which no atmospheric corrections were applied to these images. And surface reflectance that atmospheric corrections were applied to these images. The top of atmosphere reflectance variant has been available since 2015. And surface reflectance has been available since 2017. The description of surface reflectance is observable here. You are viewing Sentinel-2 bands here. The part that differentiates Sentinel-2 data from Landsat is bands 5, 6 and 7. That the plants in these bands can be identified well, and that is why they are used more in agricultural discussions. And the rest of the Sentinel-2 data are available. For example, here is the code for the cloud and snow mask. If we have a specific dataset in mind, we can enter this section. For instance, we search land cover. All the available land covers are specified. Here we can see the description of each. It has fully explained the land cover classes. For example, if we need LST data, we can search for it. And the corresponding datasets are displayed. For Landsat or MODIS, all LSTs are displayed. That we enter one of these data. The date of this image is known. So far, we have introduced the main datasets and initially registered in Google Earth Engine. Well, here we enter one of the Landsat data. For example, we choose one of these images and open the sample code. Here is the general coding environment of Google Earth Engine. In this section, the written codes are saved and can be edited. In this section, the commands that we can use are specified. For example, count command counts the number of images in a set of images. In the Assets section we can save the outputs of the codes, or import the files from this section into Google Earth Engine. This is the coding part. We can share the code link in this way. And the codes run section. And resetting. And the apps section that we will discuss in advanced sessions. Console section where all outputs will be written in this section. Tasks section which all outputs are displayed in this section at the time of exporting. We got Inspector section here, the layers that we add on the map, and we can see the pixel values through this section. It is for showing map and satellite. We can move the map. It can be used for tagging, creating geometry and placing points. We can use lines and polygons to specify the areas. We can change the color of it in the settings section. And we will mention the geometry type in the next parts. We delete the layer. When we select a layer or draw a polygon, it appears in the geometry input field. This geometry has all its specifications. The coordinate system has also been specified. Here is a sample code from Landsat. It is a function related to data shift and equalizing the data range that has been written. We will explain this part of the function code later on. Here is our dataset. And the start and end dates have been specified. Here the function has been applied to the code. In terms of image display, there is a part. Here is the map set center command that displays the center of the image when the code is run. Also, it is displayed like this in terms of display. We run the code. It displays the center of the image because we clicked map set center. The output name's been specified here. We can change the color combination. We can show it as a single band as well. This was an introduction to registration, the introduction of some images and the Google Earth Engine system itself, which in the next parts we will deal with all kinds of processes as examples and applications.